Welcome everyone, I'm Adam. For this problem, for our given vector u, which is equal to I plus 2 times j plus 2 times k, where I, j, and k are our unit vectors, we're going to be finding our direction cosines and angles of u. And then we're going to be showing that the sum of squares of the direction cosine is equal to 1. So let's first recall where the direction cosines and angles come from. So if we take a look at our x, y, z axes, we have the unit vector I as the unit vector in the x direction, our unit vector j, unit vector in the y direction of I, j, and our unit vector k is the unit vector in our z direction. Now let's consider some vector u out here in space. Okay. So first we start with the angles. So the angles of u are going to be the angles between the unit vector, say I, j, and k, and our vector u. So the angle between I and u, call that alpha. The angle between j and u, call that beta. And the angle between k and u, call that gamma. Okay, so what we want to first start doing is finding the cosines of these angles, and that's our direction cosines. So let's take a look at that. So let's start by taking a look at our direction cosines. Here, let's start with, say, the cosine of alpha, which, again, alpha, it's the angle between u and the unit vector I. So technically, this is equal to the dot product between u and I, and then divided by the product of their magnitudes. So the magnitude of u times the magnitude of I. Now, of course, we can simplify this a little bit if we just remember what happens when we have a vector times a unit vector. So u, which we'll take as the vector, say with components u1, u2, and u3, and this is dotted with the unit vector I with components 1, 0, and 0. So in the long run, what happens when we take the dot product, right, we do component-wise multiplication. So the first component u1 times 1, but then plus u2 times 0 and u3 times 0. So the only component we're going to be left with is wherever the 1 is at in our unit vector. So namely, the first component u1, and then the magnitude of a unit vector, by definition, right, is just 1. So this is going to be component u1 over the magnitude of u. And we can take that as a general formula for the other angles when we get to them. So what is u1 over the magnitude of u? So our component u1, looking up at the definition of u, the coefficient in front of I is 1, and the magnitude of u is the square root of the sum of squares of its components. So the square root of 1 squared plus 2 squared, coefficient in front of j, plus 2 squared, the coefficient in front of k. So we have 1 over the square root of 1 plus 4 plus 4, 1 over the square root of 9. So 1 over 3. So the cosine of our angle alpha is 1/3. Now we want to find the direction cosines, which we have, but we also want to find the angle. So we have our angle alpha, which is going to be equal to cosine inverse of our cosine value 1/3. And so we'll find this. So first in radian mode, so cosine inverse of 1/3, which is approximately 1.2310, and then also in degrees, just changing our mode to degrees and typing in cosine inverse of 1/3 gives us approximately 70.5 degrees. So there's the angle of u with respect to alpha. So next we're going to find the next direction cosine, So we want cosine of beta. Now again, beta is the angle between u and the unit vector j. So if we could follow the work we did up here, we know for short that this is simply going to be the second component of u, u2, over the magnitude of u, which is equal to second component of u is 2 over our magnitude, which we found in our first part, to be 3. So we have the direction cosine of beta to be 2/3. And same thing to find beta. We're going to take beta as the cosine inverse of 2/3, which first in radians, cosine inverse of 2/3 is approximately equal to 0.8411. And also in degrees, just changing our mode to degrees, cosine inverse of 2/3 is approximately equal to 48.2 degrees. Okay, and last but not least, we'll find the direction cosine of our last angle, say gamma, which again, gamma is the angle between u and the unit vector k. So the top is just going to be the third component, u3, over the magnitude of u, which our third component of u is 2, over the magnitude of u, which is 3. Okay, and so gamma, without redoing the work that we had down here, we know it's going to be cosine inverse. Well, maybe we'll fill it in for continuity's sake. Gamma is cosine inverse, again, of 2/3, but we can just copy the numbers that we have, since it's the same thing. So cosine inverse of 2/3 we had in radian mode was 0.8411, and in degree mode, approximately 48.2 degrees. Okay, so there's our direction cosines and our angles. Whew. And so the last thing that we want to do is show that the sums of squares of the direction cosines is equal to 1. Namely, what we want to show is that cosine squared of alpha plus cosine squared of beta plus cosine squared of gamma is equal to 1. So we have the values of our cosines, so we'll plug those in. So cosine of alpha was 1/3. So we have 1/3 squared plus cosine of beta was 2/3. So plus that cosine squared, 2/3 squared. And again, cosine of gamma was 2/3, so plus 2/3 squared. And we want to show that this is equal to 1. So actually, loop down here. Well, what do we have? Squaring this, 1/3 squared is 1/9, plus 2/3 squared, 4/9, plus 2/3 squared, 4/9. We have a common denominator of 9. Adding the numerators, 1 plus 4 plus 4 gives us 9, which is equal to 1. So there we have it. The sum of squares of our direction cosines is equal to 1. Thank you very much.